Okay guys, Connor. Okay, the limit of sine 3x tan x over x squared. First thing I'd do with this is I'd break up the x squared into x and x. Okay, I then look down and I realise, okay, for this to work I need a 3x underneath this and a 2x above this. Okay, and then it's limited as x approaches 0. Because I multiplied by 3 and 2 on the bottom, I need to multiply by 3 and a 2 on the top. What would then happen is these two have their formulas where these two will turn into 1 because the limit is going to 0. It's going to be 1 multiplied by 1 multiplied by 3 multiplied by 2. The answer therefore is 6. Because tan of an angle divided by the same angle goes to 0 when x goes to 0. Sine of an angle divided by the same angle also goes to 1 when x goes to 0. Okay guys, moving on. Number 20. Okay, x sine 2x. The top is grand, but the bottom isn't. Okay, I'm not happy with the bottom. So I'm going through a lot of rules in my brain here right now, and I'm thinking, okay, one of the easiest rules I could try would be cos squared x plus sine squared x equals 1. I could try that out. I could then say that cos squared x equals 1 minus sine squared x in a hope that the 1's would cancel. You're not allowed to do this. If this question said 2 multiplied by 2 cos squared x, then I'm okay to attempt it out. But because it doesn't say that, I know something's I have to change it somehow. So what I'm going to do is this. We're going to get 2, and remember 2 cos squared x therefore is going to be 2 minus 2 sine squared x. Okay, minus 2 sine squared x on the bottom. That's what the bottom changes into. Okay guys, two minus sine squared x divided by x sine 2x. Okay, so what's going to happen is minus 2 cancels with minus 2, and then we're going to get x sine 2x. It's going to be minus 1 multiplied by minus 2 is 2 sine squared x. Okay, now looking up at this, I'm trying to figure out what to do. What I have in my head is this. I have sine 2x over 2x in my head. I also have sine x over x in my head. Okay, so Dan, I've got to make as many of these as I can out of what I have. So what I'm going to do first and foremost is I'm going to take this 2 and the sine 2x, and that's what I'm left with here. On the other side, I'm going to break up the sine squared x into sine x and sine x. This x here goes here. Now I'm going to take account of what I need. I need an x on the bottom. If I put an x on the bottom, I must also put an x on top. And lucky for me, it worked out exactly the way I wanted it to. This one here will turn into 1. Next one will turn into 1, and the third one will turn into 1. 1 by 1 by 1. 1 multiplied by 1 multiplied by 1 equals 1. Okay, so that is number, what question was that? 20, okay. I'm now going on to 22. Now, number 22 is quite a difficult one. Okay, first thing, prove that cos 2x equals 1 minus sine squared x. Okay, so what I can do is this. I can go to my tables. Are you listening, guys? I can go to my tables and I can read the formula for cos 2x. What's the formula for cos 2x in your tables? Is it cos squared x minus sine squared x? I think it is. Okay, that's in your tables. Now, I compare this to this here. I have no causes, so I need to replace cos squared x with something. I'm going to do what I did in the last question. Cos squared x equals 1 minus sine squared x. Replace it with 1 minus sine squared x. And then in brackets it's going to be minus sine squared x. The answer therefore is going to be 1 minus 2 sine squared x. equals cos 2x, and that's it proven. Okay. Next part, the word hence. The word hence means that we're going to use the answer from the first part to answer the second part. Limit of cos, what are we doing? Limit of 2x squared 1 minus cos x. Now here's the problem, okay? You may have remembered earlier in the year when we did surds, and I'll give you something like this. 1 divided by 2 plus root 3. And what I'd get you to do is I'll get you to multiply top and bottom by 2 minus root 3. Okay? And what that will do is it'll get rid of the bottom. Now, in this question here, okay, I actually have no idea how to do it if it wasn't for the first part. The first part mentioned sine squareds and cos squareds. I haven't got a sine squared or a cos squared here, but I know a way to get them. The way I'm going to get them is I'm going to multiply top and bottom by 1 plus cos x. Now what I'm hoping this will do is this will I'm hoping that this will get rid of the bottom. It'll give me something to work with on the bottom that I can use, okay? So I'll show you what I mean. We have to turn this into one number. At the moment it's 2 numbers, 1 and minus cos x, and that won't work. I've said it already, you can't have addition or subtraction in this, okay? So here's what we're going to do. 2x squared times 1 is 2x squared plus 2x squared cos x. Okay? Then underneath, 1 by 1, 1. 1 by cos x plus cos x. Minus cos x by 1 minus cos x. And then minus cos x by plus cos x minus cos squared x. Now, you'll see what this has done. What it's done is got rid of it. And then on top, you still have 2x squared. What do you have on top? You still have 2x squared into 1 plus cos x. So guys, we're just going to bring it back where it was. We're going to factorize the top back where it was because it didn't prove to be any advantage. And then on the bottom we have 1 minus cos squared x. Now, for those of you who are following any of this, we're back where we started. We still have 2 numbers. See the way the 1 and the minus cos x is 2 numbers, and I said that was the problem. We still have that problem because it's 1 minus cos squared x. But there's a way of getting rid of cos squared x. Once again, like last time, cos squared x equals 1 minus sine squared x. And if we replace cos squared x with 1 bracket 1 minus sine squared x, what can happen here is 1 minus 1, 0. Minus 1 by sine squared x is just sine squared x. Now we have sine squared x over 2x squared into 1 plus cos x. Remember what chapter we're in. We're trying to get limits as x approaches 0. In the ideal world, this is what I'd have. I'd have x over sine x, x over sine x. Why did I use 2 sine x's? Sine squared x. Where did I get these 2 x's from? The x squared, not the 2, okay? And then we're going to have a 2 in front and the 1 plus cos x behind. Now, limit as x approaches 0. This here is 1. This here is 1. What's the limit of cos x as x approaches 0? 1. So it's going to be 2 multiplied by 1 plus 1, which is 2 multiplied by 2, which is 4. Okay? Okay. Now guys, that's the end of this exercise. I'd like you on page 393 now, please.